let's go into introduction of STAAD Pro. Why is STAAD Pro important and what is STAAD Pro, and basically why are software important? We all of us know that there are large structures in day-to-day life, and of course it is not manually possible to manually design them by hand calculations or any other type of calculations. For those reasons, we have these softwares available. One of the software which is very user friendly in case of steel structures, and it is used by most of the multinational companies, it is STAAD Pro. We have the full form of STAAD Pro as Structural Analysis and Design Program. This is a company called Bentley which has prepared this software, and here is some introduction that it can be used to design any kind of structure, whether it is of steel, concrete, timber, aluminium. And this code, we can apply more than 90 international codes, and it can be used to design any kind of structure, whether it is static, dynamic, wind, earthquake, thermal, moving loads, and it is used to design buildings, culverts, plants. So all kind of structures can be designed using STAAD Pro, and all kinds of load can be applied on it, and it is user friendly with most of the international codes. So there are various versions of this STAAD Pro, and we have the latest version available, STAAD Pro Connect Edition 2022, and we are going to use this latest version for our next steps. For your better understanding, I would just like to show you the website. Type STAAD Pro Connect Edition. So this is the website of STAAD Pro. From here you can understand anything in detail if you want to understand regarding STAAD Pro. This is Bentley community, but I don't want it to check community. Okay, so this is basically the website of Bentley. Here you have a lot of products of Bentley, and one of the product is STAAD Pro. Here we have STAAD. So you can design, analyze, and document structural projects anywhere in the world with any material using STAAD. You have some introduction over here, various versions of STAAD. This is the company Bentley, and we have the STAAD software. So let's go back to what we were discussing. So one of the question is, which grade of steel is mostly used for steel structures? For steel structures, generally we use mild steel, that is E250. So this is the grade of steel, which is also the grade of hot rolled sections like ISMB 600, all our India codes in our according to the Indian standards. So these all are 250 grade. Okay, so I gave you a brief overview of what STAAD Pro software is. Now, when you want to design, when you want to analyze any kind of steel structure, any kind of structure in STAAD Pro, there are certain steps what we can follow to design these any kind of element in STAAD Pro. So I would just like to show you the process of analytical modeling in STAAD Pro. First, we need to create geometry of our. To create geometry, we use nodes. These nodes are connected by beams, and the combination of nodes and beams, we create a geometry. Geometry is just lines and dots of what we wanted to create, the model. Next step, after preparing the geometry, after completing the geometry, we need to assign property to these elements. We need to assign property to these beams, whether it is a beam, what is the size of the beam, whether it is a MB 600, MB 200, whether it is a channel section or it is a plate, whatever are the properties, we need to define the properties. After defining the properties, the cross-section properties, next is the material. In our case, the material will be steel. But if you are doing anything, what is concrete or whatever is the other structure, then you need to define. STAAD doesn't know that you are preparing a steel structure. So that is the reason you have to define the material, that is steel. After that, specifications. So in these beams, sometimes you need to provide releases, or sometimes you need to assign them as a truss member. So there are certain specifications what we will understand again in detail later on. But next step, what we generally do is we apply any specification for any particular kind of beam. And next, support condition. Once we model our structure, there has to be certain support on which finally the load will be transferred. Those are called as the support condition, and we need to assign these supports in our model. This can be pin connection or a fixed connection or a combination of fixed and pin. You could have certain rotation allowed, or you could have a spring. So any kind of support. So our model needs support for stability. So next is to provide supports. After providing support, the main model is ready. Now we need to apply any external load which is coming on our model. So that is under loading. That could be the dead load of the self weight of the model, or there could be additional live load coming on it. There could be forces and loads coming due to the external wind. Also, there could be forces due to the seismic activity, or there might be a crane installed in a warehouse which is made of steel. So there is the load due to the movement of this crane, or any other kind of loading that comes under loading. You need to apply all the possible loadings on the structure. After this, what we do is we analyze. We analyze and we try to find the reactions, and we try to find the effect of the loads on our structure. This is just analysis. After the analysis part, what we do is we design. That means we design it based on the codes, whether this could be the Indian codes or the American codes or the Canadian codes or the Euro codes. Each region has their own codes, each country has their own codes. So based on the codes, we will design the elements and check whether they are safe or no, whether they are passing in strength and serviceable criteria or no. So this is under design, and then we can finalize the cross sections of our members and location of the members. So this is part of the design. Final is the post processing. That means everything, all the steps are complete, and finally we have to present the result to our client. So that comes under post processing, that is the result visualization. So any kind of structure in STAAD Pro will follow all these 8 steps. First, geometry will be prepared. We will assign properties to the geometry. We will assign material to the geometry. For any particular beam, if there is any specifications, we will give them. We will assign the supports. We will apply the loading. After this is done, we will analyze this thing and then design these things. And next is the post processing, that's called result visualization. Okay, so these were the steps. One of the question asked is, in steel structure, member is designed for elastic design or plastic design. So generally it is designed for elastic, but if there is requirement from the client, or if there is any additional requirement, then we go for plastic design. And also it depends on the cross section. If the cross section and the classification of the cross section comes under class 1, then the Indian code allows us to design it as a plastic member. When it is class 2 or class 3, or it is a slender member, then we design it as elastic member or according to the effective section. This depends on the cross section, and also generally it's designed as elastic member. Next is, what is the difference between hot rolled and cold? So these are many questions which we would be answering on later on also. But now, as we have the question, just roughly I would like to tell you. Hot rolled sections, as the name suggests, when we have die, and in that die, or a shape, a die, and in that die when we pour the molten steel, and then the shape of the element is formed like a beam shape or whatever shape, that is called as hot rolled section. But the cold form section, generally we have a sheet and we bend the sheet later on as per our requirement. Like we have for purlins, generally we use the Z shape of sheet. That is a cold form, means we have a sheet and we bent it later according to our requirement. That is called cold form sections.